Hello there, this is Stephen from EDRMedeso, and in this video I'm going to give you a simple demonstration walkthrough of a simple blow molding type application using ANSYS Fluent operating in the materials processing workspace. So let's take a look at the animation here so we know what we're aiming for. We've got a film which is being pushed into a mold and it's adopting the shape. Okay, so it's a quarter symmetry model and a nice simple example to get you started with blow molding using materials processing in Fluent. So if you've not used Fluent before in this workspace, when you start Fluent from the launcher, you'll have the option to choose the workspace below the regular operating modes, so meshing and solution. The number of workspaces that you have, as you can see, they're designed for very specific types of applications. This is determined by your license level, so Pro, Premium, and Enterprise. Okay, so all we need to do is select Materials Processing and go ahead and fire up your Fluent session. So that's going to bring up the Fluent interface, which looks like this. So you can see it's a little bit different to the regular solution mode. What we have here is essentially Polyflow, the Polyflow solver, which is embedded into the Fluent user interface. The first thing that it's asking for is a mesh. So we can bring in a Polyflow mesh. So let's go and take a look at that. I've completed this mesh in ANSYS Workbench meshing, as you can see, using 2D shell elements. So we've got a surface representing the film and this second surface which is representing the mold shape. In addition, my name selections, I've got one for each of the edges of the film. I've got one for the film surface itself and another one for the mold. To export that as a Polyflow input file, we can go to File, Export, Mesh, and you see you have the option here for Polyflow input file, and you can go ahead and export that. Okay, so let's go back to the Fluent interface here, and I'm running Fluent as a standalone application, so outside of Workbench. We'll bring in the mesh, so select the file, okay, so that's our mesh, and as you can see in the console it does report basic details about the mesh upon import. To start the setup, we're going to use a template, so that's up here in the top left. Templates are there to greatly ease your setup. They essentially populate the outline view with all of the tasks that you would need to run your particular type of simulation. So we'll go to templates, and it offers you a choice of templates. In this case, because we've got a 2D shell element mesh, it already knows that we're going to be performing a blow molding or thermoforming simulation. So that's just the only choice that we have there. Next, it's asking some basic questions about the simulation. So the number of fixed molds. In this case, we have one moving mold. So we'll leave that to 0 and set moving molds to 1. Then the number of layers of the film itself. And in this example, we have 2. And lastly, the duration, which in this case is going to be 0.5 seconds. You also have an option there to include thermal effects if you wish to. In this example, we're going to leave that unchecked. So as you can see on the left, it's populated the outline view, and you can see that the tasks that don't require any input have the green check mark. The tasks that do require input are flagged up there with the red cross. Let's look at the general task first of all. This gives you basic information about the mesh. So we've got the unit length there, and we've got the domain box size. So it's always worthwhile just checking that is as you expect it to be. Then the geometry type, 2D shell, calculation type will be transient. We've got the duration name, time there, and you can add a task name if you wish to. In addition to that, we've got the physics options. So we're going to include inertia effects. You can choose whether or not thermal and gravity are important in your particular case. Let's move on to materials now. Because I specified 2 layers, it's given me 2 fluids there. So if I select one of these are the default fluids. So you can view the properties here either by individual pause, or you can view all of the properties, and you can go ahead and edit those and customize them. For this example, we're going to use the built-in library. Okay, so if I click on Materials, Import from Library, you can see I can choose a family, so blow molding, and then I can select a material. So the first material is actually the first in the list, so HDPE isothermal 463. And I'll import a second material. So this one is PP isothermal 493. Okay, now I'm not going to use these two default fluids, so I can just right click and delete those just to keep things tidy. Okay, and the next task is cell zones. Okay, when sub-tasks are not complete, if you want some information on what you have to do, if you click on the parent or top level task, it does give you some sort of general information there. So I'll click on fluid zone, and I have to tell it which of the zones is the fluid zone. So it's going to be the film. Okay, and for this type of case, it requires an inflation pressure. So you just have to key the value in here. Okay, and next it's asking for a time dependency. So this inflation pressure will be a function of time. Now that's normally entered as an expression. I've got the expression here in this text editor for your reference there. You can see it's a simple Boolean expression. Okay, so I'm just going to copy and paste that in. Select expression from the drop-down menu. Okay, so then we move on to the moving mold. Very similar, so select the zone. Okay. And the next part we have to check is the orientation. So you can see that we've got these darts that appear on the mold. Okay, they need to be pointing towards the mold, and you can see in this case they're pointing away. So all we need to do is check this flip darts orientation box. Okay, and that puts them into the correct orientation. The motion type is going to be a translational velocity. It's going to be in the y-axis. And again, we have a time dependency function for that. So similar to the film, it's a Boolean which determines how the mold moves in relation to time. So again, I just select expression. Okay, so that's the cell zones complete. We can move on to the layers now. We need to enter the material. So the first one will be HDPE. We need to specify the zone, and in this case there is only one fluid film zone. And then determine how the thickness is defined. So you've got a choice here. You can enter coefficients A, B, C, D, and in this example we're just going to use A, and we'll leave the other coefficients at 0. And we'll do the same for layer 2. So select the material, and this will be the PP, the zone, so again the film, and again we'll enter a value for the A coefficient. We move on to the boundary conditions. You can see I've had one boundary condition inserted in there. This is the fixed edges, so that will be this edge here and this one over here. So you can apply a name, but the default is reasonable. You can specify the type, so we've got symmetry, 0 velocity and 0 force, and then you can choose the boundaries. So I'm just going to graphically select them here and control click for multiples. Okay, now you can see the top level task is still indicating that I need to do something, and that's just because these remaining two boundaries don't have any conditions attached to them. Now these are going to be our symmetry boundaries, and I'm going to create one symmetry for each so that I can define the symmetry normal axis for each of those. That would be the Z and the X respectively. So I'll click on new, and let's give it a sensible name. Set the type to symmetry, and we'll select the boundary zone. Okay, I just need to check that the plane of symmetry is correct. So normal direction along the z-axis. So okay, that's fine. And then I can create the second one. Call that symmetry 2. Set the type and pick the boundary. And in this case it's x, so I just need to change the plane of symmetry to the x-axis. Right, so now you can see that my boundary conditions are complete. I can then move on to defining the contact. So it's simply asking me what is the fluid zone of contact, which is the film, and then what is the mold zone of contact, which is the mold. That's all I need to do in this, this contact task. So we then move on to defining the fluid deformation. And again, it's just a simple case of identifying the zone. And you can see there we're done. The next option is adaptive meshing. In this case, we're not going to run adaptive meshing, but in many more complex cases, you might wish to do that. It's very difficult where you've got a complex mold to predetermine where you should refine the mesh on the film, because it's obviously going to distort when it contacts the mold. So adaptive meshing can do that for more complex cases. So that's the setup complete, and you can see if I open up solution, we have a number of other tasks that we can review. Before we go ahead and run the calculation, which we could do now, all of this is set up, we can just go to calculation activities here. This is where you would set your parallel processing. Now, in a simple case like this, I wouldn't expect it to scale or benefit too much, so I'll just leave that at the default. For larger cases, if you have parallel capability, then you can obviously increase this to see how that impacts the simulation time. For some cases, you will need to look at the transient controls, and in this case, I do know that I'm going to have to reduce the minimum time step there to enable it to get to a solution. So we can then move on to the run calculation, but before we perform the calculation, we should run a quick check. So it's telling me that the setup is valid and we can start the solver. That's just running through all of the tasks here just to make sure that everything's correct and there's no inconsistencies or anything. Okay, so let's run the calculation. As it's running, if you hit the transcript button, this is it feeding back all of the information from the solver as it's running. And a case like this may take maybe a minute or two to run through. Okay, so on successful completion, we have the message here, the computation ended and results are available. Okay, and again, if you click on transcript here, it gives you statistics about the run time here. So yeah, 60 seconds and memory usage. So at this point, we can go straight into post-processing. We'll just do a few post-processing operations just by way of example. So if I open up results down here and graphics, you can see it's got a number of mesh objects already defined. Okay, so if I display, you can see it's displaying both the mold and the actual film on the mold. So I'm just going to select the film only. Okay, and display. All right, so you can see how the film has adopted the shape of the mold there. If we wish to animate these objects, it's pretty easy to do that. You can either do it from, if you right click on results here, you've got solution history playback. Okay, or you can use the results tab here, which gives all of your post-processing options up at the top here, and you've got a time step selector here, so you can step through, rewind to the start, play, so on. Okay, so let's just create a quick contour. And I'm going to choose a field here. We're going to choose thickness. You see I've got thickness 1 and thickness 2. Okay, let's pick a surface, so that would be the film. All right, you have your regular options here for ranges and colouring and so forth. Just display that. And again, we can play that through as an animation. This being a quarter symmetry, it's also quite nice to be able to put the mirror planes on there. So again, that's up here under graphics. You have X and Z. Okay, and again, we can play that through with all of the symmetry there. Okay, another aspect that we can look at under reports over here, we can do transient plots of a particular variable. So I'll just demonstrate that now. Okay, and you can specify the type here, surface or volume, the quantity. So for example, let's look at a minimum and then choose our field. All right, so we'll go for thickness again. And we will choose the film boundary. Then you can plot this particular report. So if I click execute, so this is the thickness, or the minimum thickness, I should say, relative to time. Okay. So that's a basic run through of a blow molding application using the ANSYS Fluent materials processing workspace. I hope you found this useful and it encourages you to try this workspace. Thank you for watching.